Let's continue to take a closer look at the electric field due to a point particle, and again we're going to emphasize what's the point and try to get a more comfortable feeling with fields and field theory as we go along here. So as it says, the electric field equation for a point particle, any point particle, is kq on r squared, where of course whether we write it as a capital Q sub s or just put q in there, we need to know that's the source of the electric field. That is what the electric field is mapping in space, the effect of that source charge. Now, we said we definitely leave the positive or negative in for the Q because that is going to give us our radially in or radially out. And any of these inverse square relationships, they love that as a multiple choice question concept. So we can see that if we double the source charge, we will double the electric field at any point in space that source charge generates. It is indeed an inverse square relationship, so the electric field drops off as 1 on r squared. And again, to the what's the point of this point is that it allows for the force and acceleration on a charge q, but really any charge little q, placed at any point in space to be easily calculated based on our equation F equals QE equals MA. And again, it is so important that you become comfortable with the distinction between the Q's, that the Q in the electric field equation is the source of the electric field. If we multiply the Q in F equals QE, that Q is not the source of that electric field. That's the Q that is in space getting pushed or pulled by the electric field. So if we plot, as it shows here, electric field as a function of radial distance away from any point particle, the basic shape we get, the basic structure of the function is our 1 on r squared, so it drops off, becomes small very quickly as we move away. Note that in most problems we will have a minimum r distance that we are going to work with. We won't be going right up against a point particle. So whatever minimum r distance you are given in a problem, that would be the maximum electric field, and that would be the closest you would be allowed to get to that problem, that point in a particle in the problem you're looking at. So relatively short page of notes here, very short page of notes. So take a moment, look at what is here, and we will continue on.